Have you ever stopped to think about what actually happens when you flip a light switch? I mean, it feels like magic, but it's not. It's energy. So where does all of it come from? Today, we're going to break down the sources that power our entire world, from the super ancient to the seriously atomic, all based on what our source guide tells us. So here's what we've got on tap. First, we'll look at the big fundamental divide in our energy world. Then, we'll get into the old guard, fossil fuels, and of course, the clean alternative, renewables. We're also going to tackle the big, powerful wild card that is nuclear energy. And then we'll bring it all home to the choices you and I make every single day.
All right, let's kick things off with the big picture. Before we even start talking about solar panels or oil rigs, we've got to understand this fundamental split, this fork in the road that really shapes our entire energy landscape. It pretty much all boils down to two very different ways of getting power.
This right here is the question, isn't it? The answer to this shapes entire economies, it shapes our environment, and it definitely shapes your daily routine. It goes so much deeper than just the outlet on your wall, but the basic idea, well, it's actually surprisingly simple.
And boom, here is that fundamental split. Over on the left, we've got non-renewables. Think of these like a bank account you can't deposit into. They're finite. Once they're gone, they are gone for good. But on the right, you've got renewables. We're talking sun, wind, sources that just keep refilling themselves. For all practical purposes, they're never gonna run out.
So, let's start with the undisputed heavyweight champion of energy, the source that has powered, well, pretty much our entire modern world for over 100 years, fossil fuels.
Yeah, we're talking about coal, oil, and natural gas. Our source guide explains that these fuels come from ancient organic stuff. Literally, think dinosaurs and prehistoric jungles that got crushed deep underground for millions upon millions of years.
And this is the real catch. It takes an unimaginable amount of time, millions of years, for them to form, but we burn right through them in like an instant. That crazy imbalance is exactly why we call them non-renewable. It's an energy source with a ticking clock.
Okay, so if fossil fuels are on a timer, what's the alternative? Well, that question leads us right into the really exciting world of renewable energy, the sources that just keep on giving. To put it simply, these are the energy sources that you just can't use up. No matter how much we harness, they're always being naturally refilled, which means they're constantly available to power our lives.
And our guide really zeroes in on the big three here, grabbing the sun's power with solar panels, capturing the wind with those giant turbines, and using the sheer force of flowing water through hydropower. These are really the pillars of a clean energy future.
Now, this page from our source document just illustrates a massive advantage perfectly. See, unlike burning fossil fuels, renewables like solar and wind generate power cleanly. They do it without spewing all those harmful pollutants that can really damage our environment. Okay, so now things get a little more complicated, because there's this third major player in the energy game, and honestly, it doesn't fit neatly into either of those other boxes. That's right, we're talking about nuclear energy. In one way, it's clean like renewables. It doesn't produce greenhouse gases while it's running. But where its fuel comes from, well, that tells a very different story. So how in the world does it work? Well, in the simplest terms, nuclear power plants create a tremendous amount of heat by splitting uranium atoms. It's a process called fission, and that heat creates steam, which then turns turbines to make electricity.
And right here, this is the key thing to remember. As our guide states very clearly, because that uranium fuel has to be mined out of the earth, and there's only so much of it, nuclear power is, technically, a non-renewable resource.
But here's what makes nuclear so incredibly compelling. Its power density is just off the charts. Get this, our source explains that just 1 kilogram of uranium, which weighs about the same as a bag of sugar, can produce the same amount of energy as, wait for it, 12,000 barrels of oil. That is an absolutely staggering amount of power from a tiny bit of material.
So, okay, we've got all these incredibly powerful sources, from ancient fuels all the way to splitting atoms. But that's not the whole story, right? The other side of this whole equation is how we actually use that energy. And this is where it all gets personal. Because here's a really powerful idea to keep in mind. The cheapest, the cleanest, and the most effective unit of energy out there is the one you never even use. Conservation. That's a tool every single one of us can use, starting right now.
Our guide lays out some super simple, practical steps. Stuff like just turning off lights when you leave a room, or even small habits like not just standing there with the fridge door open. It also points out trying to avoid major appliances during peak hours. That's usually in the late afternoon when everybody's using electricity at the same time. These little actions, they really add up.
And hey, next time you're shopping for a new appliance, look for this label. This page from our source material shows the energy efficiency rating. It's a really simple guide. The closer that little arrow is to the green A at the top, the less energy it uses. Simple as that. It saves you money and it reduces the strain on the whole power grid.
So at the end of the day, from the giant power plants we decide to build as a society, all the way down to the toaster we choose for our kitchen, every single energy choice matters. It's a huge, complex puzzle with enormous stakes. So the question is, what path are we going to choose to power our future?